Now we shall see clippers, one of the important topic in analog circuits. So there are two types, one is shunt and one is series. So it is based on how the diode is placed in the circuit. If it is connected in parallel to the load, we call it as shunt, and if it is connected in series to the load is here actually, okay, at the output. So if it is connected in series, we call it as series clipper. So we shall analyze first shunt clippers. On the same basis, we'll also analyze series clippers. And before analyzing, we'll have to understand, or we have some assumptions here. Okay, assumption is whatever the drop across happens across the R and D is neglected. Here, just for understanding purpose. Later, when we deal with the numericals, we'll consider those. So input supply, basically we assume that we are giving an sinusoidal AC, and the analysis goes like this. So we are taking a case here of a shunt, a particular case. We have different cases or different models. We'll analyze each and every one of them. We analyze many circuits, that is different modules, okay, or when we understand all the different types of models, we'll get a clear picture. We get a bird view that if any kind of circuit is given, you should be able to solve it. So analysis is like this. We have a circuit. We have to draw a characteristics, or we can call it as a transfer curve. Transfer curve means whatever is transferred from input to output, we call it as a transfer curve. So x-axis is input, our reference, and what output with respect to that input we get is called as a transfer curve. And we have a output with respect to time. So how the output voltage will look like. So once we know how to draw the transfer curve, it will reflect on the output. So output is a reflect of transfer curve. Now, assuming that we have a sinusoidal input for all the cases we are taking the same input, we should know that whatever the drop occurring in R and D is negligible. Positive cycle and negative half cycle. Now the input is positive, it should go to output, but here diode is connected in such a way that whenever we get a positive to this anode, it just conducts and diverts the output to the ground. So actually output we should have got it, but everything is going down. This happens for positive. So ground means what? It is zero potential, so you have zero. So positive, any positive waveforms comes here, positive voltage comes here. What happens? It acts as a on, and internal drop, as I said, we are neglecting. When it is short, it is just grounded everything. So we don't get anything at output. So whatever the potential here, it is a short, so it means a zero here. Since it is a short line, whatever the voltage is here will also be here, right? So it will be zero. So for that, okay, what will be the characteristics? Characteristics will be like this, 0 for all positive values. Now if negative comes, it is reverse bias, it is open circuit, all the negative values goes here. So it means what? Input, if it is positive, see this is positive input, this is negative input. So for positive input, there is no output, voltage is 0. That's why this is a 0 line of y-axis, but your Vi is positive only, right? It will vary from, see here, 0 to maximum, maximum to 0. So it will vary from 0 to maximum and again maximum to 0. But in either case, from 0 to maximum, maximum to 0, the output is 0 only. That's why this is the line. Now for negative input, what is the output? Same as input, right? Everything is going to output. For negative, it is open circuit. So whatever you are giving, if you give, okay, negative input, so suppose if you are giving -1, you are getting -1. If you are giving -2, you are getting -2. So this is the point, this is the point. For -3, this is the point. For -4, this is the point. So it is a continuous value, right? So if I join this, I'll get this. So hope you understood how to draw the transfer characteristics. Okay, input is varying from 0 to maximum and maximum to 0, which is positive. So for that we have seen that it will short circuit, and whatever the potential here will be appearing here because it is a short line. Yes. So why I'm explaining in detail for this first circuit is, in detail every other module will not be explained. So concept you understand in this first module. So for positivity short, whatever the voltage is here is here. So short means ground is brought here, so it is 0. For negative, it is open circuit. So whatever negative voltage you give means -1, output is -1. For -2, output is -2. This is minus negative, right? This is negative VI. So this is the characteristics. Now actually the input is, I'm drawing it in dotted line. Okay, this is our input. So we want to draw output. So how the output will be? See, there is no slope here in this quadrant. There is no slope. So above VI axis there is no slope here. So this will not be reflected. But here wherever the slope is there, okay, you just mark a line, and wherever the slope is there, it will be reflected. This is the output. This is the waveform what you are going to see in your lab. Fine. So similarly we'll analyze second circuit. Here notice that diode direction is changed. We are going to modify this shunt circuit in many different ways. That's how we are producing many different models. And here if we analyze, if positive comes, this is reverse bias because here, okay, cathode is there, so it is open circuit. Everything will be transferred to the output. So how it will be? For positive input, positive output you are getting. For this positive input, this positive output you are getting. Okay, it is an intersection, right? So like this, for 3 volt input we are getting 3 volt output. For 1 volt input we are getting 1 volt output. Yes, so and so on. From 0 to all continuous values we get slope like this. Similarly for negative input, as I said, there is, we are neglecting the drop here. Later when we are solving actual problem we'll consider it. So for negative input, this is forward biased, everything is grounded, so ground is touching here because of short line. Okay, so it means it is 0. So nothing is, even if you are increasing the negative input, but output is 0 only. Now according to this we are assuming that this is our input. So what will be the output? It is the reflection of it. As I said, transfer curve, it is the reflection of it. So here we don't have any slope, so that is not reflected. So wherever is the slope, that much is the output. So there is slope here. Okay, you just have to move your 2 fingers here, 1 finger here, 1 finger here, and you have to move with respect to the this reference axis. You have to move to this curve, and whatever slope you are finding intersection, you will have the output. Here there is no slope, so slope is 0, so 0. Slope is 1, 1 into input is input. Okay, so whatever is the input you have received at output. So like this we are going to analyze 2 more models. Okay, but here what is the difference? Here we are putting a reference voltage VR. See here we didn't had a reference voltage, for this also we didn't had. Now we are putting a positive VR. Later for these 2 circuits we will put negative VR and try to draw it. Reference means what? It is some small voltage. What if that voltage is there? We'll try to understand. Now the analysis is same. You give positive input has come, this is forward biased. Suppose this is 2 volts. Let us take some example, and input is 5 volts. This is 5 volts. This is +5, this is -5. Means here it is +5 and this is 2. Let us assume this is 2. See, whenever we have this is +2, right? So what we do is we mark plus 2, this is plus 2, right? Plus 2 means this is plus 2, this is minus 2, this is plus 2 at output, and this is minus 2 at output. So plus 2 means we mark both on positive direction. This is positive vi, this is positive v naught, so we mark it. So this is our point. Now earlier what happened, our point was at origin, this point was origin. Now that origin point has moved, so this is a trick. But actually what is happening, see, 0 volt will start, and it will start from 0.5, 1, 1.5 and so on up to 5, correct? When it is 1 voltage, it is forward biased, means it is short. But this 2 volt is sitting here, right? When this is short, it means what? This wire is connected with this potential. This potential is plus 2. So plus 2 is sitting here. So when 1 volt comes like this and 2 volts is already sitting here, what will happen? 1 volt can overcome 2 volt? No, 2 volt is bigger than 1 volt, so it cannot overcome. So here you have 2 volts only. Initially, from input, for input 0 to 2 volts, output voltage is 2 only. So why did I draw this line? I'll tell you. So input 0 to 2 volts, you'll be getting that at the output. But when it exceeds 2 volts, when input exceeds 2 volts, what happens? This is anyway short for any positive value. Now your current, whatever comes here, is more than 2 volts, so it will overcome this. This potential is not enough, because the coming one which is higher, the higher one is coming, so it cannot withstand, it will bypass it. Okay, once it bypass it, so this is short, so whatever the voltage is here will be sitting here, that is 2 volts constant 2 volts at output. Now for example, negative, if negative comes, anyway this is not conducting, it is open, so whatever negative input you give, it goes to the output. So whatever negative input you give, it goes to the output. If you give minus 1 or minus 2, it goes to minus 2. If you give minus 3, okay, it goes to minus 3, minus 4, minus 4, and so on. So if you draw the waveform, it will look something like this. Do you agree? Because after this everything is clipped. Above this 2 volts, this is 2 volts, everything is clipped. Below that, because for that line the slope is there, so anything, as I said, you have to hold one finger here and another finger here, and you have to move your both fingers like this. Whatever is there in that slope into input is input, correct? Because slope is 1. Now you'll have to write some conditions. Okay, see, we have understood, but when it comes to problems, we'll have to write the things about it, right? So for here, if vi is less than 0, if vi is less than 0 means what? In negative, what will happen? Diode is off. Do you agree? Diode is off, output is equal to input. And if vi is greater than 0, see, for all the cases we have to write these two cases, vi less than 0 and vi greater than 0. D is on, correct? Vi greater than 0, what happens? Greater than 0 means what? Positive. Positive means diode is on. If diode is on, what will be the output? It will be 0. So this condition for everything you have to write. So similarly here, vi less than 0, D is on, okay, vi is equal to 0. And if vi is greater than 0, D is off, so what will be output? Output will be same as input. Okay, see, I have shown now 3. Okay, so rest of the 3 I leave it to you, so you have to do it. Let me do this one for you. Okay, you can try 4th and 6th. So here what happens? So negative sitting here, see, positive current comes here, it is short circuit, so it means what? Negative comes and sits here. And I have always told the shortcut. What is the shortcut? If it is negative VR, yes, this is the negative VR, right? You have to mark it on negative. Again, take 2 volt. Okay, So this is our point. Now this is showing downwards, so positive, whatever comes here, it will overcome this. So negative, okay, what will happen if negative comes? This is open, okay, so everything, all negative voltage will go to the output. So for all negative, this is the slope. For positive, what happens? It is a short circuit and it will overcome this. So this is the slope. So what is the output you can draw from here? This is the our input. So where the slope is intersecting, so it is like this. This is the output. Okay, so these two you try. Now we shall see series clippers. See, again the circuit is like this, that is diode is in series with the output. Fine. Now we are dealing the circuit directly with this, because there is no fun here, right? Input is positive. When input is positive, everything is here, and when input is negative, nothing is at output, right? So you'll simply get for this circuit, okay, you'll get something like this. So here it will be 0 for next half cycle. So it is just a half a rectifier, right? Now here, if there is a positive input, that is VR, reference voltage, what will happen? See, again the assumption here is for silicon diode the drop is 0.6 volt, which is neglected, and the drop in this resistance is also neglected. But this is for our case, let us take 2 volts, and 2 volts will always be sitting here because we have neglected resistance, right? Neglecting resistance means it is almost 0 volts, 0 drop here, so everything is here. 0 means what? Almost short circuit. So this plus VR is here. In our case, it is 2 volts. If 2 volts is here, okay, for example, and initially my input will be starting from 0, right? So initially it will be 0. So is it forward biased? No, right? Yes. For forward bias, what is the condition? The anode should be more positive than negative, or the cathode should be more negative than the anode, either of these two. So here cathode is more positive, or anode is more negative than cathode, so hence it is not conducting. If it is not conducting, it means what? For 0 to 2 volts, for 0 to 2 volts, it will not conduct. If it is not conducting, nothing is going at output. So your output from 0 to 2 volts, you will not get output. But here in slope, as I said, what is the trick here? Plus VR. So simply mark plus VR plus 2 volts and plus 2 volts on input and output. So this is VR. So we got a point, correct? So from this point, see here, output is not coming from 0 to 2 volt. For 0 to 2 volt input, just now we said that if it is 0, it is a reverse bias. If it is 1, then also reverse bias. For 2 also it is reverse bias. After 2, everything is conducting, right? So from 0 to 2, it is reverse bias. Means output you are not getting, there is no slope. For negative, is there any output? Obviously no output, right? Because it will completely block negative value, because anode is more negative than this. So there is no slope on negative side also. See, for negative also I have drawn the line from 0 to 2, there is a nothing, and from 0 to minus values also there is nothing. But after that, after 2 volts, suppose this is 2 volts, after 2 volts, 2 to 5, everything is passed to output, right? So everything is passed to output means there is a slope. So it means what? If I mark this, you should get output like this. Dotted is input, this is the output. So analysis is simple, right? So you can write it as, if Vi is less than Vr, what happens? Okay, diode is off, so output equal to Vr. Output equal to Vr because Vr is sitting here, okay? And if Vi is greater than Vr, what happens? Diode is on, then output will be same as input. So you'll have to write this. So I hope you have understood how to analyze and draw the transfer curve and its output curve for any given circuit. So the combination may be anything like this. So we are calling it clipping because this negative part is clipped. Here total negative is clipped, here positive with some reference voltage. So we can change this reference voltage, right? If it becomes 3, it goes still further down. Okay, so this is why it is called as clipping circuits. Now we'll analyze the next model. So more the model we analyze, more confident we become on this topic. That is the reason why I'm covering most of the types of circuits. So next model, so first model is our second model in series is this. So obviously here for positive nothing is going to go because you already placed it in opposite direction, reverse direction, right? So for positive nothing will go, but positive is already coming and sitting here, right? So this plus 2 volt, as I said, you'll have to mark it. So this is plus 2, and above that for any positive value anyhow it is not going to allow, right? So this is 2 volt. If it is 0 volt, 0 to 2 volts it will conduct because this is more positive than this. So for 0 to 2 volt it will conduct, but after 2 volts you whatever you give, it is becoming more positive. Cathode is becoming more positive compared to anode, so it will block. So everything is blocked. Hope you got how this curve came. Now negative, obviously for negative values, okay, it will conduct. For -1 it is on, for -2 it is on, because cathode is more negative, so it will be on, and whatever is there it will go to the output. So what will be the curve now? Yes, so it is like this, right? Okay, because of space I could not complete this. For this, can you try? Let us try. Say it is negative VR. Negative VR means you have to plot it here. You got this point. So negative VR is sitting here, so it is already negative. Negative is given to cathode, so it is forward biased for 0 volts. This is forward biased for all positive values, so all positive values will be forward biased. Okay, for negative values it will get reversed bias. So for negative input, for all negative input, output is 0. Okay, so for this what will be the curve? Curve will be like this, right? So I'll leave this circuit for you. Okay, this circuit for you, because I have solved almost 3. So one, this I'll leave it for you. Fourth model. Fifth model is a bit different. Okay, so let us take it. Now in this model positive is here, so it is in series, correct? So for 0 to positive, 0 to maximum, maximum to 0, it will be forward biased. Okay, but it will have to overcome this. Suppose this is 2 volt, so 2 volt and this is 0 volt, this is reverse bias. But if it is 3 volt and this is 2 volt, it is forward biased, and it can overcome this, because here 3 volt forward bias means it is short. Once it is short, 3 volts will come here. 3 volts can overcome 2 volts and it can go. Okay, so in this case, when the supply is here, you will have to write reference only for input, not for output. This is the key here. This is what you have to remember, or you can analyze also. So once you have given above 3 volts, above 2 volts, you will get the output. Below that 2 volts you won't get. Below 2 volts you won't get, because anyway you are not giving sufficient positive values. So this is the slope. Now how do you write this? See here, in earlier cases we had point here or above here, so we could draw like this, right? But this is on this is a bit different, correct? So this is our input. So this VR you are drawing it only here. So from this point you are getting the output. How do you draw it? So this is VR. This point we have already learned, right? Okay, wherever intersect and you drop it down, from there it starts to conduct. In piecewise model we have already learned this. So this is VR. You connect it to the main signal, input signal, and you drop it down, you get a 5. So from there it starts conducting. So this is the output. And what is the, see, it has to overcome this, right? This is in series, you have, this is an opposition, so you have to overcome this VR. That VR is this. So that is the loss. Okay, hope you got it. So anyhow there is no negative slope, so nothing will be at the output. So similarly if we analyze next circuit, okay, as I said, you draw it here. For positive values it is reversed bias, so for positive slope is 0. For all negative values you will get this kind of slope. Got it? For all negative values, initially negative value, it is there is opposition, and see here positive is given to this, so readily it will conduct for negative values. But for positive values this is reversed bias. Suppose here it is 0, you have to always take this case 0 and 2, it means it is conducting. If it is conducting, 2 volts is always sitting here. Yes, so this is minus 2 volt is already there at the 0th point. And as I said, if VR is here, if it is starting here, it means it will also start to conduct here. So this is the thing. Okay, I'll just move it. Okay, you'll get the output like this. This is the input, this is the output. Because you are raising it. For negative you are adding this voltage, this is a DC voltage. For DC you are adding, so this is up to here AC. For that some constant DC, this much DC you are offsetting. So this is the output. Okay, so for this case VR, okay, this is VR, this is also minus VR, input is minus VR, correct? So here what is this? Negative values, if you give negative input it is reverse bias, so negative side slope is 0. For positive it will conduct, so above this it will conduct. Now you intersect with this, so this is your VR, this is your input, correct? And now from here, from this VR, okay, it will conduct up to where it will conduct like this, because up to here slope is there, right? So this is the output. So last model, let me try it. So this is minus VR. Okay, so no positive values because this is blocking, because this is positive, right? No positive values. And negative value it will readily conduct, and this will add to it. So this is the slope, but this is our output. Yes, negative means this is negative, right? So it will be negative this much offset, so it will start from here. So shunt and series clipping, we have seen most of the circuits. To practice it on your own, because unless and until you analyze the things, nothing will be captured by your mind. So you have to analyze those things, and then try it. Okay, for try it for different inputs. And now next is we'll take two level clipping. Okay, two independent level clipping. There are again four models which are very easy. Tricks are there with those tricks in the sense based on what we have learned. Correct, we have learned on shunt, right? So that we have got some output. So what is the trick here? Let me show. If the diode is downwards, it means you'll get the downward signal. If the diode is showing upwards, or okay, if its position is upwards, you'll get the upward signal. This is the conclusion, right? You would have observed this. Okay, if it is downward, downward signal will come. If it is positive, it will be raised, positive side. Okay, if it is downward, downward signal will come. If it is negative, negative shift. Positive, positive shift. So these are the conclusion from shunt clipping. So that we will try to implement in two independent level clipping model, which will come for your exam generally in the form of numericals, that is problems. Now let us see independent level clipping. To look, it looks a bit complicated compared to earlier one, but it is simple because we are using the tricks what we have learned in shunt. Because diodes is in shunt, that is in parallel to the output. So yes, you got it right. So this is a combination of two shunt clippers. Now why this is used, we'll understand it. So what is the trick here? Whatever is the voltage has to be written here, and the voltage V1 is greater than V2, and we have taken an example of 3 and 2. So this is 3 volts. Okay, this is 3 volts and this is 2 volts. So 3 volts, how to be marked? How it has to be marked? Because it is positive. So 3 here and 3 here. So this is our 3 volts because it is positive. So we get this point, correct? And now this is 2 volts and it is negative. So we'll mark it somewhere here. So it is minus 2. So minus 2 Vi, sorry, minus 2 Vi minus 2 V0. So we get this point. Okay. Now we have to draw the slope. So as I said, see, for V1, diode is downwards. So this is our V1. Yes, 3 is our V1. Diode is downwards. It means anything below that, you will get a slope up to here. And for V2, anything above 2 volts, I mean for this, the output is upwards. So for this, the output is upwards. Okay, so we get this slope. Do you agree? Do you agree? Yes. See, for 3 volts, I'll repeat. For 3 volts, slope is downwards, so we have drawn. For 2 volts, slope is upwards, so we have drawn. Okay, and we get this output. So this is the actual input, correct? Now the slope is like this, and of course this is 3 volt, this is 2 volt. Fine. Now similarly, the second one, as I said, it is very simple. You just have to mark the things properly. So V1 and V2 both are positive here. So V1 is 3 and V2 is 2. Let me draw it here. So this is 3 V1. Below that, slope is there. Here above this point, slope is there. So here above this point, slope is there. Okay, so this is the thing. So this is the input. So output will be 2 to 3. Clear? Now similarly, I'll leave it to you, but nevertheless I'm drawing it. So both are negative. This is V2 2 volts and this is V3 sorry V1 3 volts. So both negative, right? So this is minus 2 and this is minus 3. So it will be in between. correct? This is V2. Okay, for V2 it is, since it is negative like this, so here below that, below means downwards, so since it is negative it is opposite, so this is the slope, and what we get here is according to that we get this. Similarly for this, V1 is negative, so 3 volts, and V2 is 2 volts. Below this, okay, there is a slope. Above this there is a slope, means it will be like this. So what will be the output? Where there is a slope, here you have like this, here there is a slope, so here you will have like this. Okay, so hope you have understood. And next topic is on clamping, that is negative and positive clamping. It is a very small video, and problems on this. Okay, I'll be doing it and adding to this video, or I'll share the separate video on numericals on clamp, and that is clipping. Yes, now we shall see a numerical on clipping. So the problem is, for a diode clipping circuit shown, so this is a shunt clipper, okay, because diode is in parallel to the output. You have to draw the input and output waveform for, okay, first case A equal to R, which is 100. Okay, second case B, R equal to 1k, and case C, R equal to 10k. So you are changing this, and you'll have to draw the input output waveform. So input here is, for all the three cases, it will be a fixed input, which is 20 sine omega t, and you have to assume that forward resistance is 100 ohm and reverse resistance is infinity. So when the diode will be on, okay, when the diode will be on, see, this is 10 volts, VR is 10 volts, they have already said it, correct? Yes, VR is 10 volts. Let me change the color. So if VR is 10 volts, okay, so assuming this is ideal, 10 volts is sitting here, so output will always be 10, okay, and anything more than that, input more than 10 volts, you will get it in output. So for that, what we'll have to write, if Vi is greater than or equal to 10 volt, okay, your D is on. Next, when Vi is less than 10 volt, D is off. Okay, and in that case, what will happen? In that case, V0 will be Vi. So this is the equivalent circuit, okay, of the above figure, correct? Equivalent circuit, we have simply replaced D with forward resistance when it is on. When the input is 0 to 10, okay, which is less than 10, what happens? This is more positive, actually it should be more negative than this, so this is more positive, so this is off. When this is off, okay, it is open, so whatever you give at input straight away goes to output. But when it is greater than 10, it is forward biased, so it is short, so 10 will be sitting here, and above 10 whatever you give, it will go to the output. Okay, so we shall solve it. We have already seen some formula by applying KVL in piecewise model. Now the same formulas will again apply. So if you apply KVL for this, output will be VRF plus VR. Okay, or it is it's not KVL, it is output equal to this voltage drop plus this voltage, which is nothing but Okay, VRF is nothing but I into R, Ohm's law, plus VR. But we also know that, as I said, I is VI minus VR whole divided by VR, sorry, it is R plus, right, R plus RF. So if you substitute this here, okay, what you'll get? You'll get V naught is equal to this RF as it is, R plus RF from the denominator, okay, you'll get VI minus VR plus VR. Nice. So this is a template what I have drawn. I have not yet drawn the output, so let me drag it a bit below. So we have got a equation. Now when will be output maximum? Okay, see, we'll have to know the maximum value when the output is maximum, when input is maximum, right? Output is max when Vi is max. Okay, so what your output will look like? This equation, if you rewrite this equation, it is RF by R plus RF into Vi max, okay, because that is the only variable, everything else is constant. So Vi max is what? 20V actually, correct? And what are the other details you have? VR 10 volts and RF equal to 100 ohms. So everything else required is written here. So we'll see the first case. Okay, for R equal to 100 ohms, what will be the output? Output max will be 100. In this formula we are substituting 100 divided by 100 plus, yes, R is 100, it is already given in the problem, yes, first case, and RF is also 100. So left out term is 20 minus 10 plus 10, which comes out to be 15 volts. So similarly for second case, for R equal to 1k, if you are increasing the input resistance, what will happen, we'll see. So V naught max, okay, this is V max, V naught max equal to 100 divided by 100 plus 100 into 20 minus 10 plus 10. Okay, so it is 1k, right? So this is 1000. So what will happen? You will get it around 10.9 volts. So similarly for R equal to 10k, V naught max 100 divided by 10k plus 100. So again it is 20 minus 10, which is 10 plus 10. So this is comes out to be 10.1 volt. Okay, and when we know that when D is off, okay, V naught is equal to Vi. We already seen this. And for all the three cases, V naught min is what? V naught min is same as V in min. Okay, so which is minus 20. So if you want to draw, so this is the orange line is input, orange dot line is input, and this is fixed. Output is negative as it is, and as I said, 0 to 10, whatever is the input, that is the output. So output changes only for this. So for third case it is 10.1. So for third case I am drawing it here. For second case it is 10.9, case B 10.9. It will be slightly higher because you can understand it, right? 10.9 is almost 11, so somewhere here, and first case is 50 nodes. So you will get almost like this. Got it? Hope you understood the problem. I had kept it everything ready so as to save the time, and please go through this problem again for better understanding. So that's it, we have completed the clippers. Now in next video we'll see